Let's do some practice problems. We'll look at Lewis structures where the central atom is surrounded by either 5 or 6 things. And then I'll talk you through the thought process for how to determine what the three-dimensional VSEPR shape for the molecule is and what the bond angles are. Okay, if you haven't already done it, you might want to watch VSEPR videos part 2 and part 3 to talk about the background information for this stuff, just so that we're on the same page. Okay, so here's our first Lewis structure, and this is for XCO2F2. The first thing that we want to ask ourselves when we're figuring out the VSEPR structure is how many things are there around the central atom? So xenon here is a central atom. There are these 2 double bonds to oxygen. Remember, in VSEPR, double bonds count for the same as single bonds. It's just a bond to an atom, okay? So 1, 2, 3, 4 bonds, and then a lone electron pair. So there are going to be 5 total things around this atom. So number 2 asks, what structure is this molecule based on? What I mean is, if something has 5 things around the central atom, it's based on a particular structure. It's going to be based on this shape here, which is trigonal bipyramidal. So this is the shape, trigonal bipyramidal, that we want to have in our minds. Okay. Now, what I mean by based on is that if the 5 things surrounding xenon were all atoms, then it would be a trigonal bipyramidal shape. But they're not. Okay, they're not all 5 atoms. So number 3 here asks which atoms are replaced by lone electron pairs. So in this molecule, there are 4 atoms and then 1 lone electron pair, which means that one of the atoms in this trigonal bipyramidal molecule is going to be replaced by a lone electron pair. Now, if you remember from what we said earlier, it's the equatorial atoms that get replaced by lone electron pairs first. So that means that our final structure of this molecule is going to look like this, where you can see here one of the equatorial atoms has been replaced by a lone electron pair. Okay? But keep in mind that they're very similar, that this shape, which is called the seesaw shape, is based on and related to the trigonal bipyramidal shape. It's just, it's missing one of these equatorial atoms and it's been replaced by an unshared electron pair. So this molecule here has a seesaw shape. Let's talk about angles really quickly, okay? In the trigonal bipyramidal, there is a 180-degree angle between these 2 atoms here. And if we look from the top down, there's 120 degrees between each of these atoms. Okay. Now, in the seesaw, we have this unshared electron pair here. And as we've said before, unshared electron pairs push harder against atoms because they want a little bit more space. So that means that these 2 atoms are going to get pushed closer together like this, meaning that the angle between them is going to be less than 180 degrees. If we look at the top-down view of this, we see the unshared electron pairs here, and they are pushing these atoms together, which means that if we look at this top-down view here, these atoms are getting pushed together, so the angle between them is less than 120 degrees. So that's what the angles are for this seesaw molecule here. BRF3, what's its VSEPR shape? Okay, step number 1. How many things are there around the central atom? There are 1, 2, 3 bonds and 1, 2 lone electron pairs. So 5 total things. So then what structure is this molecule based on? Well, any molecule that has 5 things around the central atom is based on this trigonal bipyramidal shape. So now question 3. Which electrons in this are going to be replaced by lone electron pairs? So this has 5 atoms, but BRF3 only has 3 atoms, and then it has 2 unshared electron pairs. So what it's going to look like is this right here. Look at how similar this is to the trigonal bipyramidal shape, but it's that 2 of these equatorial atoms, maybe say this one and this one, this one and this one, have been replaced by unshared electron pairs. Here are the unshared electron pairs, these 2 and these 2. Okay? So what that causes is this T-shaped molecule. This has a T-shape, and in terms of angles, we just looked at these angles a minute ago, and the T-shaped is going to have an angle that is less than 180 degrees between these two atoms, because these lone electron pairs are going to be pushing inward on these two atoms. It's also going to mean that the angle between these two bonds is less than 90 degrees. So these are both less than 90 degrees, and then this whole thing from here to here is going to be less than 180. So that's what BRF3 looks like, a T-shaped molecule, because two of these equatorial atoms from the molecule that it's based on have been replaced by lone electron pairs. Okay, IOF5. First thing we ask, how many things are there around the central atom? There are 1, 2, 3, 4, 5, 6 bonds. Remember, double bonds, single bonds, they count for the same. 6 bonds around this central atom. So, what molecule is it based on if there are 6 bonds, 6 atoms around the central atom? It is based on an octahedral molecule. Oh, that was the wrong one. It's based on, there we go, that's my octahedral molecule. It's based on an octahedral molecule. Now, which atoms are going to be replaced by lone electron pairs? They're not going to be, because there are no lone electron pairs in this molecule. So that means that every single one of these atoms is going to be in place here. And my final structure is going to be octahedral. And just to brush up on the angles, every single one of these angles in an octahedral between any two bonds is going to be 90 degrees. They're all right angles. So this was really easy. 6 things, 6 atoms, no unshared electron pairs, and you have an octahedral molecule. ICl4, okay, and the whole thing is surrounded by these brackets because it has a negative charge, which means this whole clump of atoms has received an extra electron. Doesn't matter if it has a charge or not, we go through figuring out what the VSEPR shape is, we go through it exactly the same way. Don't be thrown off at all by this charge. It doesn't have any effect on the VSEPR. Okay, anyway, first thing we ask, how many things are there around the central atom? 1, 2, 3, 4, 5, 6. 6 total things. So, what structure is this going to be based on? It's going to be based on the octahedral shape, which looks like this, which normally has 6 atoms around a central atom. Okay, number 3, which atoms are going to be replaced by lone electron pairs? Octahedral has 6 atoms, but ICl4 here has 2 of them replaced by lone electron pairs. And so this is the structure that I'm going to end up getting, where you can see that if you make this comparison, the top and the bottom atoms, if you like to think about it that way, have been replaced by an unshared electron pair here and an unshared electron pair here, and I'm left with 4 around the middle here. And the shape that that gives me is square planar, because these are all kind of in a plane, just like that. And in terms of angles, my octahedral, as I said, has 90-degree angles between every bond, and the square planar, if we look at this top view down, it's really simple too. It's got 90 degrees between all of these bonds here. And that's because these unshared electrons push down, but these electrons on the bottom push up. So there's no net movement of any of these atoms because they're being pushed up and down the same amount, so they stay exactly in the center, and there is a 90-degree angle between each set of those bonds. So that's what we get, a square planar molecule when we take 2 of the atoms off of an octahedral molecule and replace them with lone electron pairs. SOF4. Okay, how many things are there around the central atom? There are 1, 2, 3, 4, 5. Double bonds count the same as single bonds. 5 things around it. So the structure that this molecule is going to be based on is the trigonal bipyramidal shape, which is how you arrange 5 things around a central atom. Now, which atoms are going to be replaced by lone electron pairs? None of them, because there are no lone electron pairs in this Lewis structure. So that means that our SOF4 is going to just look like this. It's going to be a full-on regular trigonal bipyramidal molecule where These are 180 between these two bonds. These are 90 degrees between these two bonds, and from the top down, each one of these bonds has a 120 degree angle between it. Trigonal bipyramidal for 5 atoms around a central atom. I3, and then the whole thing has a 1 minus charge. So how many things are there around the central atom? 1, 2, 3, 4, 5. Okay? How do we arrange 5 things around a central atom? It's going to be based on this pyramidal, on this trigonal bipyramidal shape that we just looked at a minute ago. Okay? But now, which of the atoms from this 5 atom shape are going to be replaced by lone pairs? Well, they're going to be 1, 2, 3 lone pairs instead of 3 atoms. So this one's going to go, this one's going to go, and this one's going to go. And here is the shape that we get left with. Okay? You can see this atom stays, obviously the central atom stays. Here they are. But now if you look at it from the top down, these 3 unshared electron pairs have replaced the 3 equatorial atoms in this trigonal bipyramidal structure. Okay? So this leaves us with a linear structure where the 3 atoms are all just in a row. Okay? And the way this relates to what we saw before is normally we have a 180 degree angle between these 2 bonds. And it turns out that in a linear structure, we have the exact same thing, because sure, there are all of these unshared electrons, but they're all pushing equally against this one and this one in all directions, so nothing gets bent up or down. They're all just bam, bam, bam in a straight line just like that, 180 degrees between them, with 3 of these unshared electron pairs around the central atom, on the replacing the equatorial atoms. Okay? Last one, TeF5, and the whole thing has a negative charge. Okay? How many things are around the central atom? 1, 2, 3, 4, 5 bonds, and 1 lone electron pair, 6 things total. So that means that the structure of this is going to be based on the octahedral molecule, which is this right here, octahedral. Which atoms are replaced by lone electron pairs? So instead of having 6 atoms like I do in a regular octahedral, one of these atoms is going to be replaced by this lone electron pair. So that means that my structure is going to look like this. Check it out. I just cut its head off and replaced it with a lone electron pair. This atom is gone, and it's been replaced by these electrons right here. Okay? So this is going to give me the structure that we call square pyramidal, because if you look at it like this, it sits up, looks like this, kind of looks like a square pyramid. So, really quickly, bond angles in a regular octahedral molecule are all 90 degrees. Bond angles are all 90 degrees. And in the square pyramidal, we have these unshared electrons that are pushing down. They're pushing down on all of these atoms a little bit. So that means that the bond between this and this, between this and this bond is going to be less than 90 degrees because these are getting pushed down. And since these 2 are getting pushed down, they end up a little closer together, which means that the bond between these 2 is a little less than 90 degrees as well. So take one of the 6 atoms away from an octahedral molecule and you end up with something that has a square pyramidal shape. Okay, so that's how you go through and look at a Lewis structure and figure out what its 3-dimensional VSEPR shape should be. A lot of people really freak out about VSEPR and they think there are all these different structures that they have to memorize. You know, they make the flashcards and they have all the bond angles and everything. But really, VSEPR is not that hard if you think about it along these lines, like you're going through these steps here. You figure out how many things are around the central atom, what structure is that based on, like maybe it's based on the octahedral, and then you just think about which of the atoms are going to get replaced with unshared electron pairs, and that will tell you the structure that you end up with. Just 2 things to keep in mind. When you have a trigonal bipyramidal molecule, you always replace the equatorial atoms one at a time. So if all 3 of them are replaced, you end up with this linear molecule. On the other hand, when you have an octahedral molecule like this, the first atom you replace, well, it doesn't really matter, but it looks like it's at the top. And then the second atom you replace, instead of being one of these, The second one is on the other side. And you get this structure here, where this has been replaced and this has been replaced. But anyway, you don't have to memorize a whole lot with VSEPR. All you have to do is understand really well how you start with the structure that the molecules are based on, and then you just figure out which atoms to remove. And always remember that unshared electron pairs push atoms closer together. So if there's an unshared electron pair pushing atoms, their angle is going to be less than it is in the perfect structure that the molecule is based on. Okay, so that's how you can figure out a VSEPR structure based on a Lewis structure.